Okay, we're in the home stretch of the chi-square test. So at this point, what we're going to try to do is say for our wine and music example, how would we finish the test? What calculation would we perform? How would we come up with a p-value? And how would we interpret that? Let's remind ourselves that the chi-square statistic, this is the formula that's straight off of your purple formula sheet, simply says that we're going to take the sum of all the observed counts, and notice these are counts, not proportions, minus the expected counts. We're going to square that, and we're going to divide by the expected count, and then we're going to sum over all of those. So for example, the wine and music example that we've been using, there are 9 cells in the table, there are 9 observed values, 9 expected values, so this sum would consist of 9 parts added together. If you take a look at the work that's shown on page 859, they actually show you on that page the specific calculation for each one of these. You can see that each pair of observed and expected values is brought together in a single calculation, and there are 9 of those. It's a very long calculation. There's lots of parts to it. So one of the things, of course, we're going to have to decide is, well, what are we exactly going to write down, and how are we going to generate those values in a way that shows our work? Right now, though, let's just get a feel for how we're going to do it. We are going to rely on technology to a large extent to help us with the calculations so we don't mess it up with all those parts. That would be a very easy thing for us to do. On page 860, if you turn to that page, the box at the very top of that page gives us a roadmap of where we're going to head. Notice that the first sentence talks about using independent SRSs from each of C population. So they're SRSs, they need to be independent of each other. That's going to be important as we're looking at condition checking. And we have C populations. All that means is it's probably more than 2, or I should say 2 or more. It could certainly be 2 populations, but it oftentimes could be 3 or 4 or 5, but there are a number of populations. Each individual has to be in a sample, and then within those populations we break them into R categories. So we have R categories in each population. So in our case, our C populations were, we had 3 populations, each one was a type of music being played, and then the R categories we had 3 categories there. They could either buy French wine, an Italian wine, or some other kind of wine. And that's how we ended up with a 3 by 3 sort of distribution. Our null hypothesis would be that in each of the C populations, we have the same proportion of individuals in the categories. So within each population, we have the same proportion of individuals in each categories. So notice we're saying the same proportion, not necessarily the same count. Okay? That in other words, that there's not really any difference between them. The alternative is going to say that being in one population or another is going to make a difference in terms of what categories you might end up in. Notice that also in that box, if the null is true, that we have a new distribution called a chi-square distribution. If you look at the picture on that page, you might notice the chi-square distribution is not symmetric. It is right skewed. And so the chi-square statistic is going to fall at some point near the tail. And what we're going to be trying to do at this point is determine the p-value by looking at the area shaded to the right of the chi-square statistic. Okay? The degrees of freedom in this case are going to be the product of the rows minus 1 times the columns minus 1. So in our case with our wine example, we would have 3 minus 1 times 3 minus 1, or 4 degrees of freedom. So a slightly more involved degrees of freedom calculation only because it has to have both the rows and columns accounted for. Now, look at the cell counts that are required at the bottom of page 860. It tells us that we can use this test with critical values from the chi-square distribution when no more than 20% of the expected counts, notice it's expected, not observed, that when no more than 20% are less than 5, so if they're all above 5, we're done. If any of them are below 5, it can't be more than 20% of the total number of cells available. And all of the individual counts have to be at least 1. So that's kind of similar to what we saw with the goodness of fit test. There's just a few more things to check. Again, as long as we have counts of 5 or greater, that's the only thing we have to check. It's only when they're less than 5 that things get interesting. So let's put all this together at this point. Take a look at page 861, and let's see about how music and wine are linked as it would run as a test. So in step 1, again, we're back to looking at population and parameters and trying to get our hypotheses. The populations are the different types of music, or the bottles that are being purchased as the different types of music are being played. The hypotheses, that the null would be that the distribution of wine is the same despite all the different music types. So the null, the distribution of wine does not depend on music. That's the way we could say it. Doesn't matter what music you're playing, the distribution of wine purchased will be the same. The alternative is that the distribution of wine purchased does depend on the music that's being played, and we are pretty sure that's going to be the case. All right, step 2, notice in the conditions, we've already calculated the expected values, and we're confident that that they're all greater than 5. The smallest one that we had was 9.568, so we meet that requirement. The data are also supposed to come from independent simple random samples from the population, and so we are kind of saying, we're assuming that they are simple random samples in that particular case, that, for example, one set of data wasn't being collected right before the Christmas holidays, whereas the other one was some random week in February, that there was some care taken in that. In step 3, our calculation, which we saw on the previous page, gives us a chi-square statistic of 18.28. We have some experience with this, but of course we have a little bit more work to do. Notice that the degrees of freedom we already calculated were 4. So this is a place where you could stop the video and do the chi-square CDF command to see what the p-value is going to be. So go ahead and stop the video and do that. If you calculate this either using the table or using your calculator, you're going to find out the p-value is a very small 0.001, which would definitely give us strong evidence at this point to conclude that we can, reject our null hypothesis in favor of the alternative and conclude that the type of wine being purchased is dependent or connected or related in some way to the type of music being played. This gives us an idea of what the chi-square test is going to look like with just using the standard calculation techniques. When we're in class, we're going to also work this through on our calculators to come up with this because, of course, as we know, after we've carefully done all these expected value calculations, getting the chi-square statistic is computationally not a trivial thing. So we're going to use our calculators later on to help us with speeding up that process a little bit.